In today's video review, we continue with our Radxa X4 coverage. This is a single board computer a lot of people in the home emulation and gaming community have been talking about. In the last video, we kind of took a comprehensive look at everything the board has to offer. We took a look at 4 operating systems, what this thing can do in terms of emulation, as far as what you could expect in terms of productivity with this type of board for $60. Now, for the price point, it's very hard to argue that this isn't one of the top 22 boards for 2024. For $60 to $80, if you're getting a 4GB version or 8GB version, and even now up to 12GB included with eMMC, this is definitely a competitive board for its price range. Now, we ran a number of different emulation tests. I've even demonstrated a tiny bit of PlayStation 3. I really don't think it's quite there yet. We've done some PlayStation 2, cloud gaming, and a lot of other things that we've ran. But specifically for this video, as I promised, we wanted to offer a supplemental video with our additional testing. And this is going to really refer to productivity, heat temperatures, and the thermal padding. I know it's really been a big issue. I spent a lot of time testing it. But again, this is an Intel-based chip. This chip is made to get hot, unlike ARM single board computers like your Raspberry Pi 5s and your Orange Pi 5s RK3588 are usually going to range anywhere between 55 with a full maximum load pressure up to about 80 degrees in Celsius. However, these Intel-based chips are made to get hot. They are made for 12 volts and made to do a robust number of things on these particular chipsets using the N100. So again, with this, you can get up to temperatures for about 105 degrees Celsius. Now, the only problem is a lot of people are reaching thermal temperatures or thermal throttling before they can really get any productivity out of that. And that has been pretty much the consensus of report for a lot of people. However, in this particular video, what I am going to do is I am going to use the defaulted pads. I used thermal paste on the last one. I'm going to use the pads only, not apply any form of thermal paste, and see what our temperature values are for our testing. Now, I'm going to run a number of different tests, which should pretty much give you guys a better indication. Some people have reported getting up to 100, 105, or at least a little bit more in terms of what this board is concerned, because this could be an issue. Because what is the point of having a board like this if you're thermal throttling and you can't get the full productivity out of it? Now, again, it's my understanding that the Radxa company has replaced the original thermal pads, which is what you're going to see in this video, with something a little bit thicker. And again, as you guys saw from my last previous test, I didn't have any problems with thermal throttling or any heating. In fact, my cool temperatures were roughly about 34 degrees, 34 to 36 on the low end, and roughly about 60 at maximum load after doing a number of hours of heavy throttling. Now, what I'm going to do is I want you guys to see exactly how I apply it. I will fast forward a lot. Conscientious sake, I know a lot of people will have questions. I'm going to do my best not to speed it up too fast or edit out any incremental parts, because I know this is a simple process, but it has been widely talked about. And since I know that there are a lot of other single board computers coming out that will have Intel-based chips, we might as well go ahead and nip this in the bud, see what we could do, how we could apply it, because there's been a lot of different applications in terms of people using other passive cooling techniques in order to keep this thing cool. And I think that is a little bit overkill in terms of what we need to do. And we definitely want to see, is Radxa supplying us with the recommended tools, what we need to use in order to maintain stability for this type of device. So let's go ahead and get into it. Now, for the sake of this video, again, the company did send me over a review unit, which was the 4GB version. However, I since ordered 2 more additional Radxa X4s. Why? Because they're freaking cool. I need to have a bunch of these, right? So I will be using my own personal 8GB version in order to run this test. And based upon a number of other tests that I've already previously ran, I can confirm that the 8GB version and the 4GB model of this are pretty much going to run the same. So the company sent over a review Radxa X4. This is the one here. And as you guys know, with this particular unit, I applied thermal paste to it in addition to the thermal pads that they do provide it. Works perfectly fine. In fact, I was just online looking at the Radxa forums, and apparently one of the guys who works for Radxa said, yeah, you should get about 30 degrees temps, and then I guess somewhere between 30 and 60, somewhere around that. And ironically, that's what I'm getting. I got about 62 degrees under full throttle. So the purpose of this one, and this is my personal Radxa X4, I have a third one on the way. I'm only going to apply the thermal pads they sent over. I'm going to do this test for about maybe 5 minutes or so. We're going to use Supreme X1. As you guys know, I've been averaging about 33 degrees temps on that, up to about 36. I don't think I'm going to run a full load on that. We just want to see what the idle temps are to see if there is a significant difference. I know there's been reports that some of these aren't really working. So what we're going to do is we're going to apply both thermal pads. I'm going to take this one here, do it this way, and then I'm going to take the second one and then just lay it flush here. After I do my initial test, I'm then going to separate them. Hopefully I don't make a big mess out of all of this. And then I'm going to do what I did with the other one, is I'm going to apply thermal paste between the two pads. So that's actually how I'm getting the good cooling on the other Radxa X4. The only thing that may throw off my test, and I'm just really speculating here, because I like to be consistent with everything, is the one they sent me is a 4 gigabyte model. The one that I purchased here is the 64 gigabyte, 8 gigabyte of RAM version. So hopefully we have the same make and model. As you guys know, there's been some things even in the Raspberry Pi community where we've talked about where people have said, hey, the 8 gigabyte is just is pretty much the same one with the 4 gigabyte. However, it was a different architecture and all that other stuff. So other than the RAM and other than the eMMC storage, they should be the same. Obviously, I like to be a little optimistic, but they should be the same for the most part. That should not throw off any type of consistent test. I won't know the consistent test until I apply thermal paste, just like I did the 4 gigabyte model. So let's go ahead and get started. So we're just only going to apply the thermal pads that the company sent over, and let's see if we could reduplicate the same heat signatures and cooling solutions that I'm getting on the 4 gigabyte model that I've already set aside to do that. So let's go ahead and begin. All right, so at this point, we're just going to line up the thermal pads and unpeel them from the plastic. We just want to make sure that everything is lined up. Now, again, these are kind of brittle right now. I'm just making sure that everything isn't falling apart and that we can properly place the thermal pads directly on the Intel chip processor. Now, as you can see, it's kind of falling apart a little bit. So this is when I realized that they really weren't of high quality. They look like they've maybe been sitting around for a little bit. So again, I'm just peeling everything off piece by piece. We're still going to move forward, but again, I want to keep this test as realistic and show you guys exactly what I did, because even in these working conditions, I definitely just wanted to see if Radxa X4 could maintain its cooling with me just pulling off the thermal pads. Not exactly pretty, but it is getting the job done so far. All right, so I'm just going to pull everything off. Again, I'm just going to separate all the pieces here as I pull them off. Again, this is a true user experience, and I am aware, again, like I've said before, that they have changed the thermal pads. They are a little bit better, but first-person user experience to know exactly what you guys would get, even if they were still using this particular set. Alright, so I'm pulling off the pieces one at a time, and we're applying them directly to the Radxa X4. Now, I also wanted to make mention that this is the particular unit that I ordered myself. Remember, I know the company sent me one over for review, as well as it's with the cooling case. However, this is the cooling case that I bought through RAs. So the thermal pads and everything is typically what you would also buy if you order directly through them as well. All right, I'm just manually applying everything by hand. Obviously, I couldn't roll it on or just press it down, so I'm just kind of taking piece by piece and making sure that they are as spread out as humanly possible. All right, looks like we got a nice little decent spread here. It's not as good as what I think it should be, but pretty much this is what it's going to look like. And then what I'm going to do is take the additional pieces and apply it directly to the cooling case. But right now, I think I primarily have most of the processor covered right now. And if I was using thermal paste, what I would do is then just take that thermal paste and apply it to the rest of the base itself. We know the chip is actually covered, but that entire base, it needs to have thermal protection as well. All right, I'm just picking up the pieces here, just applying them. What I'm doing is kind of measuring how I have them on the Intel based chip and then just kind of spreading it out so that way it creates a nice even spread all the way around. So that way that there is no direct connection between the chip and the cooler. Now I'm just taking out the screws, getting ready to set this up to mount it to the board. As you notice, this is the way you should properly install it. Make sure you hook up the fan directly to the cooler before you mount it to the board. Just making sure everything fits perfectly safe, perfectly well. Then I'm just going to go ahead and screw it down to the board itself. All right, so we're pretty much just finishing up here. We're getting ready to mount this to the board. Everything's nice, tight, and secure. And once we do that, we're going to hook up our HDMI cable, install our power connector, and let's see exactly how our temps will compare. All right, so let's go ahead and get ready to boot up Supreme X1. Again, this is using a Debian base. And we're going to boot up into the KDE Plasma desktop. All right, so here we are booted up on the desktop, and lo and behold, we finally have our first temperature reading coming in at the low temperature of 37 degrees Celsius. So it all works out. I haven't been able to reduplicate the heating issue. We're going to run some bench tests to see if we can heat it up and then let it cool down and see if it kind of stabilizes. But for the most part, everything seems to kind of be consistent, coming in at 37 degrees Celsius, which is what I ran in the last video, measured against the 3 operating systems other than Batacera. You guys remember Batacera came in at 53 degrees on idle, and I think it bumped up to about, what was it, 60 or something or whatever it was. Now I know currently on the screen you guys are still seeing the temperature reading on the Supreme X1 Debian build. Remember, the sensors aren't working. If you guys are looking at that temperature setting, it says 27 degrees Celsius. Go ahead and ignore that. That is why I had to go ahead and install a separate temperature gauge direct program running on the Supreme X1 build. And now we're going to run some basic bench testing. I believe I ran 2 tests on this. And so that way we can kind of get the CPU up to speed a little bit. And as you guys can see in the background, temperatures just dropped to about 35 degrees Celsius. And then it's going to go up to roughly about 65 degrees. All right, so here we have it. We are now at 71 degrees Celsius. It looks like that has been our current max. In the background, we have a system monitoring tool, so you guys can see the CPU usage in the back as well. Right now, the RAM is being tapped out at about 44 degrees, not 44 degrees, but at 44% on the RAM usage. And then on the CPU usage, we are at about 27 to 28. It is kind of spiked up to about 30 or so. And I believe we're running a Geekbench test. And then, of course, later on, I've also ran Sysbench as well. But again, this is just to give you guys an overall look. Again, the whole method was to get this thing to overclock. As you can see, it is kind of peaking out at 73 degrees Celsius, and then the max temperature has went up right now to about 93 degrees Celsius, and we're maintaining an average temperature of about 45 to 60 degrees Celsius while we're running the overclock or the stress test here on the Radxa X4. All right, so it doesn't appear there's anything I can do to really heat this up. You know, besides this test, you guys can see the resource meter in the background. We tapped out at somewhere around maybe 90 degrees Celsius, but this was my solution, so apparently it does work, even with the defaulted thermal pads that a lot of people expressed concerns with. But I know Chris from Explaining Computers, he used a copper shim, which is also another brilliant idea. Again, you want to just make sure that the CPU chip is flush with the cooler, with the case on that board. So other than that is pretty much it. The only other thing I think I could have done was maybe run Kodi. I know Kodi typically makes an ARM-based chip run about 20 degrees hotter than it normally does, and then maybe run some video editing. But for the most part, this board is performing the way Radxa advertised it, coming in at around 35 degrees Celsius. So if you guys have any more questions, if there's any more tests that you suggest or think that I should run, please let me know in the comments section below. Again, this runs really great with emulation. And again, I had some other people ask me, why do I concern myself so much with maybe idle temps? Reason being is because when we start running demanding applications like PS2 and maybe some of the other applications, maybe Bitcoin mining, you always want to know what your baseline is. And so you don't want to start off with a temperature on this type of chip at around 60 or 70 degrees. And then that way, when you start throttling or trying to get more use out of it, or actually putting a load on it, you don't want to end up at about 90% or 105% or anything like that, or 100% at all. You want to know where exactly your baseline is. You want to keep it as cool as possible. Make sure you always know what your temperatures are, because when you start running these demanding applications, they will push the board, even if you're using a Raspberry Pi 5 or one of those other boards, which, you know, would typically boost it up to about 20 degrees. And even in that case, with like a Raspberry Pi 5 or Orange Pi 5, my defaulted temps were somewhere about 27, 28 degrees Celsius, and in some cases I've gotten up to 55 to 61 because you throttle at 80. So same thing applies here. You always want to try to keep your temperatures as cool as possible, because that way when you start to put a load on it, you know exactly what threshold is not going to hit. Case in point, a few of my buddies have messaged me. They said this is some of the coolest temps that they've seen on the N100 for future reference, and so they were trying to get me to heat this up for this experiment. So I will catch you guys later. Let me know what your thoughts are below. Please check out the Patreon, and if you do like this channel, I also have some affiliate channels as well as Facebook groups that I run that you can find in the description of this video. So I will catch you guys later. Peace out and have a great day. Bye bye.